solved a couple of problems using binary search. I hope you guys tried that out, after the class. And yeah, even if you have, even if you haven't, my recommendation is definitely do it, because like it will help you in understanding and dealing with more complex binary search questions when we will be doing it later in the course. So today, in today's agenda is not binary search. Today's agenda is something different, which is the concept of two pointers. So what is two pointers? So I briefly discussed it yesterday, but let's discuss it now in a little more detail. And then today we will be solving a couple of questions related to two pointers. Okay, and I'm pretty sure by the end of the lecture you will be having a little bit of idea of what's going on. So what is two pointer basically? So as the name suggests, we will be having two pointers. And by pointer, I don't mean the address pointers. I just mean you will have two variables. Okay, let's say two variables I and j, and these two variables will help you in figuring out your solution. So how will they help us? So basically, what happens in two pointers is you keep your I at the first index of the array, and you keep your j at the last index. This is the general case. Not every question will have this. Okay, this is a very general case. In fact, the first problem which we will be solving today will not have this condition. We will be keeping our I and j both at index 1. So there are multiple ways of doing it. The point of two pointers is to reduce your search space. So the logic remains the same. In binary search, what did we do? We had gotten ourselves a search space, and we were at every iteration we were ignoring half of that search space, right? So the left hand side, for example, this particular from 0 to mid, we were ignoring for some condition, and we were only searching in this half of the array. So now that's why binary search is very efficient. Why is it efficient? Because it ignores half of the array at the same time, and that's why the time complexity is log of n. But binary searches cannot be used everywhere, right? Like not every problem can be solved by binary search. So there are some problems which can solve by using the technique of two pointers. And in two pointers, what happens is we don't ignore the entire half of the array at one single go. We simply increment our I by 1 or decrement our j by 1, basically 1 places. So here, that's why, like, since you are decrementing 1 by 1, you will have to do an order of n time traversal to basically reduce your search space to a single point. So I will keep on increasing, j will keep on decreasing, and after a certain point, you will get here at a particular point where you will find the value that you are looking for. Now, binary search is used for searching. It's the primary purpose of binary search is searching. But that's not the case for two pointers. Well, two pointers do search, but they a little more than that. And we will see everything that I have just said right now. Like, this is just the theory. We'll understand it a lot. Like, I'm pretty sure you guys still have some confusions of how two pointer works, and it will get clear when we will start solving questions. So with that basic theory, let's get started on the questions. So the first the first problem that we'll be solving today is remove duplicates from sorted array. So as the question's name suggests, it's pretty obvious what the question is asking us to do. So what does it say? It says that you are given an array, a sorted array. Okay, so you are given a sorted array. For example, you have 1, 3, 5, 8, 10. Okay, these are the 5 numbers. But now in this sorted array, there are multiple duplicates present, and they are also in the sorted manner only. So for example, there are 4 1s, there are 3 3s, there are, say, there is 1 4, there's 2 3 5, there is 2 8, there's 1 9, and then there are 2 10s. So you can, as you can see, there are multiple duplicates here, right? So what do we do? What the question is asking us to do? The questions asked is very simple. It's saying that instead of having this 4 1s, whole number of 1s, just have a single 1. Instead of having this 3, just have a single 3. There is only 1 4, so have a single 4. For 3 5s, have a single 5. For 2 8s, have a single 8. For For one 9, have a single 9, and for two 10s, have a single 10. But you have to do this in place. So there is a concept of in place. What does in place means? This is your input array, right? For example, say this is your nums array, which is your input array. You need to do every changes. Your result should be present in this array itself. Now, what is the size of this array? The size of this array is 4 plus 3, 7, 8, 11 to 13, 14 to 16. The length is 16, right? And after removing the duplicates, how many numbers are there? 1, 2, 3, 4, 5, 6, 7. 7. Now, many languages, okay, many languages, including C++, Java, Python, they won't let you change the length of an array from 16 to 7. So how will we approach this problem? The problem says that you don't have to, create a new array, do whatever you want. So this is your input array, right? Your nums array. In this nums array, do this. The first 7 elements should be 1, 3, 4, 5, 8, 9, 10. And for the other 9 elements, for the rest 9 elements, do whatever you want. They don't care. You can leave it as underscores. You can leave it as basically like in this problem statement, I have mentioned underscores here. Like for example, if your input is 1, 1, 2, your output should look like 1, 2, and then an underscore. Why an underscore? Because it doesn't matter. It doesn't matter to the, compiler. It doesn't matter to the interpreter. It doesn't matter to the interviewer what you're putting here. You can put anything you want. In fact, just have these duplicate numbers here. Whatever, for example, there are three ones are duplicates, right? Only one is the first occurrence. So for those 3 ones, they can stay here. It doesn't matter. But for the rest of them, they need to be here. Or you can replace all of these numbers by 0, okay, because 0 is equivalent of null. So this is what the problem asks. Now, again, like usual, take 5 minutes, think about the solution, think about the brute force or optimized or better. Basically, like think how you can, achieve this. Definitely, first present the brute force approach. So what's the brute force approach in this case? Well, there are a lot of ways of doing it, in the brute force manner. So I will be showing you one of them, which, comes to my mind in the first place. So whenever you see duplicates, one of the way of doing this is, to use a set. So what is a set? Basically, one second. What is a set? A set is sort of like an array. Okay. But what is the property of set? Set will only contain a single element. It won't contain more than one element. So for example, there are 4 ones. Keep on, adding them in the set array. So for example, you take a resultant array. Okay. And in that, there are 4 ones, like right? So you traverse this array using an I pointer. And then what do? Yes, exactly, Tanya. Set does not contain duplicates. That's the property of set. It cannot contain duplicates. So add all of these 4s, like basically take your I, okay, and then start traversing. And for every element, add it in your set. So first, your I is at 1, okay, add that into your set, resultant array. Next, again, go to 1. Add that again into your resultant array. But this time, set won't accept it. It won't throw an error. It won't do anything. It will just keep on running. Again, a 1 comes. 1 is already present, right? It does not care. The same thing happens. Now 3 is not present in the set. It will add 3. For the next 2 3s, it won't do anything. Again, for 4, it will add 4. For 5, it will do the same thing, and so on and so forth. This is one brute force way of doing it. Another brute force way of doing it is tracking the duplicate elements, tracking the unique elements using a hash map. For example, if you take a hash map, okay, let's take a hash table. You found 1, okay. So just add 1, comma, or just add 1, okay. Basically, you can add true as well. It's up to you how you want to do it. For every other one, since it's already present, you don't have to do anything. Similarly, add 3. Similarly, add 4. Similarly, add 5. 8, 9, and 10. And after adding all of these, just traverse your, just traverse your hash map. When you traverse your hash map, you will find all of these elements been occurring once. So you can just print them in your array. But what's the demerit of this? Both of these solutions can be done in O of n, right? But what's the demerit of this? Like time complexity O of n. because we also want the time complexity of O of n only. We don't want O of n square or something like that. We want the time complexity of O of n, and we are already getting it using a hash table. But the issue here is that the space complex, exactly, the space complexity is also O of n. You are taking an extra space. So, and the problem has strictly told you not to take an extra space. One sec. And the problem has strictly told you to do this in place. See, taking an extra space is not a viable option here. So this is the first solution that you should present in an interview. Now, what's the next solution?